All right, we're gonna try something a little different this time when I videotape. I'm just gonna go from the book versus using the computer so that I can kind of draw better and write things out for you guys. So today's lesson is 31-3, and we're gonna talk about actually graphing the quadratic function. So this is if they only give you the equation and they ask you to graph it. Some of you have kind of figured out some different ways already of how to do that. This lesson should be pretty simple. It's just going to show you some quick ideas to do that. So they start off right away with an example here. We have an equation x squared minus x minus 12. So they suggest the first thing you should do is find the axis of symmetry. So one of the things we learned yesterday was to do x equals negative b divided by 2a. Okay, so they look here, and I know that my b is an invisible 1, my a is an invisible 1, actually my b is an invisible negative 1, and my a is an invisible positive 1. So if I were to plug those into the equation here, I would figure out that my x, my axis of symmetry, equals 0.5. So I know that my line that goes down the middle is going to be at x equals 0.5. Okay, so find that. Now I can plug that number in for x and solve for my vertex to find my y. So if I plug 0.5 in for my x, so plug it in, 0.5 squared minus 0.5 minus 12, and I solve that, I now know that my y is negative 12.25. So my vertex is at 0.5 comma negative 12.25. So I now know either my maximum or my minimum. I can go back up here and look, it's positive, so it must be a happy face, so it's going to be a minimum. The next suggestion is to find your zeros of your function, which was Monday's lesson. That's just finding where it's going to cross the x-intercepts. Okay, so we factor this out. What times what equals negative 12 and adds to a negative 1, a negative 4, and a positive 3. Okay, so we factor those out, set them equal to 0, and we solve. So x is going to equal 4 and x is going to equal negative 3. So now, just based off of the equation alone, I have figured out my vertex and I have figured out my two x-intercepts. So now I can graph it. So they went down here in the example and they showed you, okay, here's my vertex is 0.5 and negative 12.25. I know it crosses at a positive 4. I know it crosses at a negative 3. And then I can just draw my parabola there. That's really all that this lesson is about, is just showing you that if they give you the equation only, that we can use the things that we've learned on Monday and Tuesday to find our axis of symmetry, find our vertex, find our zeros, and then graph it. That's really all it is doing today, okay? So here they want you to practice that. So here we have a couple different equations. So let's do a couple of these. I'm not going to take up too much time, but I do want to practice this a couple times. So let's just work on b for right now. If I have y equals x squared minus 2x minus 8, I'm going to do like we did over here in the first thing, and I'm going to find my axis of symmetry. Okay, so if I have negative and my b is a negative 2 divided by 2 times, I have an invisible 1 here, 1. Okay, this is going to become a positive 2 divided by 2, which equals 1. So I know my axis of symmetry, is when x equals 1. Now I can plug that back into my original equation here. So I have 1 squared minus 2 times 1 minus 8. This is going to tell me what my y is. So 1 squared is 1 minus 2 minus 8. 1 minus 2 is a negative 1. Minus 8 puts me at negative 9. Okay, so my y equals negative 9. I now know that my vertex is at 1, negative 9. Okay, Now I can go to the next step they suggested, is to find my zeros of the function. So if I actually factor this out, then I can find where it's going to cross. All right, so what times what is going to equal -8 and add to a -2. So I know it's going to be my 4 and my 2. In order to get a -2, I need to have my -4 and my +2. I would set both of these equal to 0, so it really becomes x is +4 and x equals -2. Okay, so if I were to graph this, I'm just going to do it kind of down here. I know that my vertex is at +1, -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's my vertex at 1, -9. And then I know that it's going to cross at +4. 1, 2, 3, 4. And it's going to cross at -2. 1, 2. Okay, so then this would be my parabola, and I'd be done. Okay, if it just says to graph the quadratic function, find the vertex and the zeros. I found my vertex and I found my zeros, and I graphed it. Okay, it'd be good to label. So like I labeled that this is at 1, -9, and then this would be at 4, 0, and this is -2, 0. So it might be good to label your 2 zeros and label your vertex. But that's really it. That's all that this lesson is about, is using Monday and Tuesday's lessons to find your axis of symmetry, find your vertex, find your zeros, and then graph everything that you just found. Okay, they do have some like real world application there. So again, remembering what this would look like. So this one's talking about a trebuchet again, so they're launching something. Okay, so it's probably going to have that frowny face look to it. Okay, whenever you're reading a real world problem, make sure see if it makes sense. So notice how they set up this graph to where it doesn't really have the negatives, because we shouldn't have a negative distance from the launch point. Okay, and we shouldn't have a negative height. That's just real world application, that it's going to be maybe starting at the ground and going across, or maybe it starts up here and then goes down. Okay, so just think about the fact that realistically it's not going to have negatives there. Okay, so that's really it for your lesson. It does have a few more examples in here for you to solve. You're going to again set it up with your -b/2a, find your axis of symmetry, plug that back in to find your y, which ends up giving you your vertex, and then factor it to find your zeros, and then graph those 3 points on a graph. So it does say to label the vertex, the axis of symmetry, and the zeros. So if I were to label my axis of symmetry back on this one, I would label, that'd be this line right here that goes through here, and it's x equals 1. That would be my axis of symmetry. Okay, so if it asks you to label each of your things, make sure that you label them. Okay, so your homework 31-3, so you've got you're going to have to look at each of these and figure out which one would be in quadrant 1. So when we're doing this, here's quadrant 1 right here, positive, positive. So which of these would end up in this positive, positive up here? Okay. Up here, you're just trying to figure out which of these equation matches this. So find which vertex matches, which zeros match. Okay. Here, which of these is a true statement about this graph? So just read each of these statements and see if they fit this. Okay. And then lastly, it's got a real world application. She's throwing a basketball up from the ground toward a basketball hoop. Okay, so she's throwing it, she's throwing it up at a basketball hoop. Okay, you could even draw your little basketball hoop. She's throwing it up there. Okay, so it tells you the parabolic path and returns to the 4 or 5 feet from the hoop. So it's going to go down after there. Okay, so write an equation that would represent that. So that's it. Not very much homework. Pretty simple, making sure that we understand. Don't forget to turn in any homeworks from 31-2, which was Tuesdays, and 31-1, which was Mondays. Okay, so that is it for your lesson. Super short, super easy. Do well.